Hello there, and welcome to WAHEY Productions Maths Revision.
I'm Carne DURKIN.
And I'm Will Carne.
And today we're going to whiz through half of Core 1.
This video has got all you need to know for that evasive A star.
But if you have any questions, you're more than welcome to ask in the comments below.
Let's get going with surds and indices. Now, surds are roots that cannot be expressed as rational numbers, or to be honest, any root sign that you can get rid of.
Yay, can't get rid of, by the way. Take root 20. You know that 20 is the same as 4 multiplied by 5, which can be separated into root 4 multiplied by root 5, which becomes 2 root 5, as you cannot simplify root 5 any further, but you can simplify root 4 into 2, as root 5 is irrational.
Which, if you are clever, you can prove, but that's it. That's where you leave it as. Root 20 becomes 2 root 5. How lovely.
Clever people. If you have a surd forming part of a fraction where there is a surd on the denominator, you can simplify it by rationalising that denominator. Or the bottom bit.
Just multiply it by 1, but where 1 is a clever little trick.
Yeah,
but swap the sign over of the surd, which sort of effectively creates an inverse different of 2 squares on the bottom. It just means you get rid of any surd on the bottom of your fraction.
By squaring it.
Yes.
Indices, as in those numbers with the random numbers floating next to them, simply have a lot of rules that you need to learn and follow.
To multiply the numbers, you add the indices.
To divide the numbers, you subtract the indices.
Number to a negative power is the reciprocal of the number to the positive power.
Any value to the power 0 always equals 1.
A number to the power to a power just means you multiply the powers.
If the indices is a fraction, then it means the root of the power.
So, just learn them and you will be fine. On to algebraic expression.
Now, one thing you should always look out for is the difference of 2 squares. Whenever you have 2 squared terms separated by a minus sign, that's a sign of what we've just done.
There's a sign of...
that you've just had a quadratic that has cancelled out the middle x term, so you only have this.
Yeah.
Here's a nice example on the little
There's
screen.
an example.
Look at that.
Note it only works that way. If there is a plus sign, then it's likely they don't factorise nicely, if they factorise at all. On to fractions quickly. As you've been doing this for over 5 years, we're going to do this very quickly. So to add them, you make the denominators the same, and then you just add the top.
Yeah. To multiply, just multiply them. To divide, just multiply by the reciprocal or 1 over your fraction.
It's all very easy.
Simple.
Yes, so on to some equations and quadratic functions, and to completing the square.
When it comes to factorising anything in C1, I tend to use this method rather than the formula or any other way, simply because it gives you the minimum and maximum point of that graph, which they usually like to ask for.
So you take the second term, halve it, and put it in the bracket. Then take away, always minus, the number in the bracket squared, and then you just carry the number that you have left down.
Then simplify.
That's it. Now, to find the roots, you will have the equation equaling 0.
So simply take the number over and simplify it.
If you have an x squared term with a coefficient other than 1, then you divide the whole equation by it, sort of in the first stage, if that makes sense.
When it comes to the minimum and maximum points, they occur at the point, in this case of -2, -9, or the number in the bracket with an opposite sign, and the y value is just the number outside the bracket.
So, if you're asked to sketch the graph, then I would complete the square, as you get everything you need to know, even if there aren't any roots. You still, obviously, will get the minimum or maximum point.
And remember that the y-intersect is just the number at the start on its own, but you already know that.
Onto the discriminant, or this blue bit here. Essentially, you can see how many roots there are by just doing this bit of the equation. Or, if you're feeling lazy, if the discriminant...
Which we all are.
Is less than 0, then there are no roots.
If the discriminant is greater than 0, there are 2 roots.
And if the discriminant equals 0, then there is only 1 root.
Only 1.
Now there's quite a lot of information. So here is a cat and a beret.
Oh, look at that. Hashtag meow.
Inequalities now, which can be either linear or quadratic.
Linear being straight lines and quadratic being those curvy ones, the squiggly.
With linear inequalities, where x has a maximum power of 1, you can kind of pretend it's an equal sign.
Kind of. Adding, subtracting, multiplying and dividing by positive numbers all work as they do with an equal sign, so they get the ducky of truth.
However, multiplying and dividing by minus numbers don't work, so they get the ducky of shame.
Dun -dun.
But if you turn that inequality sign upside down or around, then you can do it, and it will work fine.
Mostly. It will.
It will work fine. Don't ignore him.
On
to quadratic inequalities, and those involving other polynomials, and to the WAHEY Productions quadratic inequality and those involving other polynomials system of helpfulness.
That's a mouthful.
Oh.
Start off by rearranging to get your polynomial or equation with different degrees of x on one side and 0 on the other side. Simple enough.
Then swap the inequality sign for an equal sign temporarily, and then just solve it as usual.
Then sketch the graph, marking where the line intersects the axes.
And finally, solve using the original inequality sign.
What do I mean? We shall show you.
Take the example where you get take the example where you get roots of 3 and minus 1.
Ta-da!
If the inequality is less than, then you're talking about the area less than 0, so the area underneath the x-axis shown by this ducky.
Look at the ducky.
So one region where x is greater than minus 1, but less than 3.
Simples. When the sign is more than, there are 2 regions above the line shown by the duckies, so the answer is x is less than 1 or more than 3.
Yep,
That's the
so you
minus
have
one.
2 different, if you have an or equal to sign, then you just add the little line. Really, it makes no
difference.
Yeah, it just means you're including the x-axis in what you're
line.
blabbing on about.
Make sure you draw the graph though, because if your equation has a negative x squared, then you know the graph must be upside down. So there will only be one region when the sign is more than. If that confuses you, then just remember to always draw a sketch.
But of course you will, because they always follow our guide.
And
it's part 3 of our guide.
Yeah,
so. On to simultaneous equations now, the last part of this video, and something that you have been doing for years, we will zoom through it.
2 methods are available to use substitution or elimination, but we both tend to use substitution because it always works, so you might as well, use that. It always works no matter what the number is.
However, with elimination, the first step is to match the coefficients of one letter in both equations, and then if they have the same sign, then subtract. If they have different signs, then add the equations.
Whereas with substitution, you rearrange one equation so that there's a single letter on one side, and then substitute that into the other equation where that letter is.
Step 3 is the same for both. You solve the equation for that letter.
And then step 4 is the same for both, which is substituting your answer into one of the equations and solve to find the other letter.
Some tips: if there are fractions or decimals, then multiply through both equations to get rid.
If there's a common factor, then divide both equations to make it simpler.
And of course, don't forget to check your answer back.
Check everything.
That's always good.
You've probably done it wrong. No.
That's it for part A. We tried to keep this very quick, informative and helpful, and I hope it was.
Feel free to ask anything in the comments, or tell me I'm a babe or I'm useless, as many of you have and surely will.
Already, yes. So good luck on your exam for the second half of Core 1. Go and listen to part B. I've been Will Carne.
I've been Quadratic.
And I thank you oh so much for listening.
I do as well.
Bye.
Bye-bye now.